As you all know that I'm doing a GATE previous year question for the strength of materials. Okay, and the topic is stress and strain. Before starting this lecture, I want to tell you I've already completed one video for this. So if you're watching first time, so please see the previous lecture also, because there I have completed I think 10 question from the GATE previous year. Okay, so this is a little bit about myself. So let's start, and we'll see few more questions related to stress and strain that already came in GATE exam. Okay, so this will be helpful for mechanical engineering as well as for the civil engineering students, because the strength of material is one of the course for the civil engineering as well. Okay, so let's start this video. Okay, so this question is of 2004, GATE 2004. So let's read the question. In a bolted joint, two members are connected with an axial tightening force of 220 Newton. If the bolt used has a metric thread of 4 mm, then torque required for achieving the tightening the force. Okay, so let's see what is this question. Okay, so as we know that torque is what is force into radius. Okay, so this force is given 220. Okay, and this radius will be, okay, so we have to divide with 2 pi. Okay, then we'll get the it is a pitch. Okay, pitch is given, so if you divide with 2 pi, we'll get the radius. Okay, so this will be the entire expression. Okay, so 200 into 2200 into 0.004 by 2 pi. So if you simplify this, you'll get 1.4 Newton. Okay, so answer will be C for this question. Okay, so okay, I hope you understood this question. See, this GATE 2004, sometimes people say that this is the one of the toughest paper of any of the GATE years. Okay, because for the mechanical engineering, I don't know about other branches. Okay, so each and every question was people say very tough. Okay, and if you corrected correctly 20 or 25 question in this exam, okay, so you can easily get any of the IITs. Okay, so this was the level of the paper. Okay, if 2 marks question, I'm talking about 2 marks question, if you attend correctly solve 20 question, so you will score of some 40 marks. So the 40 marks was enough for getting any of the IIT in this paper. Okay, now we'll see more question. See, if you see this question, see how many places this question came. See, this question came in GATE 2004. Okay, then IES 1995, 97, and 98. Okay, and it has been repeated in engineering services examination in 1997 and 1998. Okay, so what is the question? Let's read this question. The figure below shows a steel rod of 25 mm square cross sectional area. It is loaded at 4 points KLMN. Okay, so assume elastic modulus is 200 gigapascal. The total change in length of the rod to the loading. Okay, see, actually what is given here, there is one rod is given, and there is 4 sections there, 3 sections, 1, 2, and 3. So they are asking what is the total, and they have applied forces in different directions. See here, 100 Newton, 50 Newton, 250 Newton, 200 Newton. So now they are asking, so somewhere there will be tensile, somewhere will be compressive. So they are asking what is the total elongation. Okay, so I will tell you how to solve this kind of problem. Okay, might be many of you already know that, but okay, if you still don't know, please see carefully how this question will solve. Okay, okay, see what we have to do that in this question. See, there is 3 sections, section 1, section 2, this is section 1, section 2, and section 3. Okay, so see, so what we have to do that, we have to calculate elongation in all three sections separately and with with sign and with and then add all. Okay, or you can say that see the where the tensile force is acting, where the compressive force is acting. If for tensile force consider positive, for compressive force consider negative. Okay, so the elongation you know that, okay, that is delta L is equal to PL by A. Okay, so we have to calculate PL, I mean delta L for each section, for this and for this. But see, what is the problem here? We don't know what is the force and which direction force is acting in all three sections. Okay, so what we have to do, we have to first we have to get forces in all three section, whether it is we have to see whether it is compressive and whether it is tensile, and what is the magnitude of that. Okay, so let's see how to do that. See, see the first section, KL section. At point K, 100 Newton is tensile. So what you have to do, you at this point, okay, so you here this direction in tensile direction, in compressive direction, add 100 this side, 100 this side. Fine. Then what will happen? Just separate this section, separate, and consider the tensile. See, here is tensile, here is tensile. Okay, so you will get 100 tensile in KL section. Okay, now see this L point. L point, what is happening at L point now? 250 in this direction and 100 in this direction. Okay, so what will happen? There will be, so we have to see 250 in this direction, 100 in this direction. So we can get 150 in compressive direction. Okay, so 150 this side, 150 this side. Okay, and you can start from this side also. Okay, so if you start from this side, you will get this. Similar way, we have to add 100 here, 100 this side. Similarly, like 50 from this side, 50 from this side. Okay, so the way we have done for this, similarly we have to, like once you do one you will get for other two. Okay, fine. So here will be 150 and for this will be 50. Okay, actually I think here it will be compressive. Okay, this is actually wrong. This will be compressive, because you can see here this is 150, 250 compressive, or 100 is what? 100 is tensile. So if you add both, so you will get 150 compressive. Okay, and from you can see here. So then again to counterbalance this 150, we have to add this side 150 and 150 this side. Okay, and here is what? 200 and 150. So 200 minus 150 will get 50. So this side will be 50. This is actually wrong. Okay, so it will be compressive, it will not be tensile. So in this section, 100 tensile, 150 compressive, 50 compressive. So now we have to calculate separately delta L for this, delta L for this, delta L for this. So for delta L for KL section and ML section it will be positive, and for 150 for LM section it will be negative. And if you add all, you will get B minus 10 micrometer. Okay, you know everything. Okay, force you know that, area you know that, elongation you know that. Now your force you know that. Okay, and length you will get the length also, because this is 500, and you can subtract 900 from the 1700, you will get this length. Okay, you will get this length, and then you can put all those value here separately, get delta 1, delta 2, delta 3. So this will be obviously negative, this will be positive, this will be positive. If you add all three, you will get minus 10 micrometer. Okay, so I have not solved that. I have told you how to solve this. Please solve this question with your own. Okay, it will be very helpful for you. Okay, is not happy, it will be very good practice for you. Okay, so I thought you understood this explanation. Okay, see see the next question again. See the almost exactly similar kind of question came in grade 2006. Okay, so here everything is given, like area is given. Okay, now they are asking the value of stress in the segment. See here they are not asking elongation, they are asking stress. So stress will be force per unit area. Okay, so what we have to do, that we have to get force in each section and just divide with the area, you will get stress. Okay, so they are asking in QR, this section they are asking. So let's, okay, so the explanation is same. I will not take more time for solving this question, because in the previous question I have taken a lot of time to explain that, but still I will tell you little bit. So what we have to do is consider this part. Okay, add this side 63, add this side 63. Okay, so this 63 will be for section 1. So now you can see here, this side it will be 63 and 35. So just subtract 63 minus 35, will get 28. So again this 28 we have to add this side. Okay, this side and this side. Okay, so take tensile 1, so this will be 28, and anyway this RS is not required. Okay, so now just subtract 28 from 29, you will get 21. Okay, so they are asking for the QR. Okay, they are asking for QR. So you have 28 kilonewton, just divide with the 700. Okay, just divide with the 700, you will get 40 megapascal. So answer is A. Okay, so it's a simple question. I mean, if you know, if you listen me carefully, the previous part, this question you can very easily you can solve. Okay, so this is the GATE 2006 question, which answer is A, 40 megapascal. Okay, I hope you understood this explanation and this question. Next question. See here, mass and spring system is given. Again, this is GATE 2004 question. Let's read. An injector mechanism consists of helical compression spring having a spring constant K is equal to 981 into 10 power 3 Newton meter. It is pre-compressed by 100 mm for its free state. If it is used to eject mass of 100 kg held on it, the mass will move up through a distance. See, actually we no need to solve this question, its answer is A. Okay, because no calculation is needed. As per its compression is compressed by 100 mm from the free surface, free state. Okay, so the remaining, see, you can see other see, this is given 981, 1500. So this is beyond the range of the spring compression. So obviously its answer will be A. If you see the answer, you can no need to solve this question, simply you can take that. Okay, because these are beyond the range. So its answer is A. Now next question, what is saying? A uniform cylinder rod is made of homogeneous and isotropic material. The rod rests on the frictionless surface. The rod is heated uniformly if the radial and longitudinal thermal stresses are represented by sigma R and sigma Z respectively. See, this kind of question, just remember one thing. See, any rod, okay, if it is simply rest, okay, there is no support from any side, okay, and if you are hitting, so there will not change in any of this. Okay, so its answer will be A. Okay, yes, we can say that it is a free, so no thermal. If it is a free, means no thermal stresses will develop. Okay, so its answer will be A. There should be some constraint from any side, then only there will be stress. Okay, since it is a free, so no thermal, since it is free, so no thermal stresses will develop. Okay, the answer will be A for this question. Fine. The next question. the test specimen is stressed slightly beyond the yield point and then unloaded, its yield strength will be, its answer will be B, increases. Okay, so this is the diagram for this. Okay, if you unload, then stresses will increase. Okay, so unload, yield strength will increase. Okay? There is no much explanation required for this. You just, this figure is enough for this explanation. So answer is B. Now next question, under the repeated load, a material has a free stress strain curve shown in the figure. Which of the following statement is true? Okay, so it is stress strain curve is given. So they are asking which one is true. The smaller shaded area, the better the material damping. The larger the shaded area, the better the material damping. The material damping is an independent material property and does not depends on the curve. None of these. Okay, so it will be A. Okay, its answer will be A. The smaller the shaded area, the better the material damping. Okay, you just remember. Just memorize it. Okay. The smaller the shaded area, the better is the material damping. Okay, so I have completed few more questions from the stress strain. I think yeah. From next lecture onwards, I will take question of engineering services. Okay. I hope you like this video. Thank you for listening. Bye bye.